Okay, here's our standard sane demented problem. And what we know about it is that, you could start with population vector 1000, right? So that vector is the vector (1000). Or you could start with the population vector here. And of course that vector is 0, 1000, and you have 1000 here. Okay? But when you start multiplying by this matrix, wherever you start, what can you tell me about the vector you get? Well, the one thing you can tell me is because S plus D equals 1000, where of course this is the number of sane, this is the number of demented, we know that this matrix doesn't change. And if we do a general, R1 minus S, 1 minus RS matrix in symbols, we can confirm that that matrix for any R and S between 0 and 1 is not going to change the total number of the total of the two numbers that you have in the column vector you multiply by, right? We established that first day. First day we talked about this, which is the second day of class, I think. Well, S plus D equals 1000 tells us that D equals S minus 1000. That's a straight line with vertical intercept 1000 and slope -1, isn't it? Okay? So this is the line because this arranges to D equals 1000 minus S. On this graph, that has a slope of -1, a vertical intercept of 1000, which of course runs it through 1000 here, right? Now, knowing that S plus D is 1000, we know this is linear, right? Unlike some bonehead that originally told you, there was some kind of curve. Okay, don't know who would do that to you, but somebody might have. So again, you can't totally trust anybody, not even the person who told you that. Okay, so what we know is that your vector that you get from any transition has to lie on this line. If you start with 1000 people, you end with 1000 people, so you've got to be on this line. In other words, the tip of this vector has to be on that line. What else do we know? Okay. You've got a line of slope 1/2 that the vector has to lie on, right? I'm sorry, that will give you an unchanging population. Any vector on this line, when you multiply it by this matrix, gives you the same vector. Okay? Now, if you have S plus D equals 1000, that vector has to just come out to this line, right? So we have this stable population vector. Such that if you multiply by this matrix, you get the same vector that you started with. Okay? And that means, of course, well, I'll write that out later. Don't want to digress to it right now. Okay, then what happens? Well, wherever you are, you're kind of following a sequence of vectors that is going to look something like this. Vectors get closer and closer together, and this represents what happens when you multiply a vector by this matrix, right? Okay? And we've talked quite a bit about that. And the same thing happens over here. So it's like you got a vector here, to draw that very well, and then a vector here, a little closer to this one, then a vector here, a vector here, and they kind of blend together, and you can't really separate them apart. So the vectors, the population vectors approach this purple vector on this red line as a limit. Okay? We know all that.
Mm-hmm.
That was well done.
I'm glad I didn't knock anything over. Thank you.
Nobody got hurt. You guys deserve some credit too. You got out of the way. That was good. Now, I'm not sure what to do about this power cord.
We just
So I'm just going to turn the camera off. We're going to deal with that.